The physical meaning of gyromagnetic ratio is that magnetic relative contribution of the magnetic moments due to spin and orbital angular momentum. Because, and when we, in the absence of magnetic field, or when you apply magnetic field, mu b mj means that basic magnetic moment, elements of elementary magnetic moments due to the magnetic quantum number, and also B means that applying magnetic field, and the Gj is that the gyromagnetic ratio is that the factor proportional factor depending on the magnetic moment. But here this gyromagnetic ratio component has the total eigenvalues of the total angular momentum and the orbital angular momentum and spin angular momentum. So, and depending on the quantum states, and the gyromagnetic ratio is different. And in this case, and the basic elements of magnetic moment, and it depends on the quantum state. So magnetic moments depending on the quantum states. So let's have an example. Let's have an example for hydrogen 2p state. Hydrogen 2p state is that here P means SP, so L equal to 1 in this case, and S spin is that 1/2. So J is that L plus minus S, so there are two possibilities, J equal to 3/2, in other words 1/2. So in this case, and here Gj means that here J in the case for 3/2 case 1 plus J is that 3/2, and J plus 1 is that 5/2, plus S is that 1/2, and S plus 1 is a 3/2, and minus L equal to 1, so it is a 2, and also 2 times J equal to 3/2 times J plus 1 is that 5/2. So here this numerator is that 4, 3 times 5, 15, plus 3 minus 8 is that 10 over 4, and in the denominator it is that 30. So it comes that 1 plus 1/3, so it is 4/3. In the case of the total angular momentum is 3/2, it is the gyromagnetic ratio is that 4/3. In the other case, in the 1/2 case, is the 1 plus, and the J is that 1/2 times 3/2 plus 1/2 times L equal to spin. Here it is L equal to 1/2. Minus 2, and also 2 times 1/2, and 3/2. Then in this case, in this numerator is that 3 plus 1 minus 8 minus I'm sorry. It is 3. So it is 3. So minus 2. And also here it is 6 over 4th. So it is that 1 minus 1/3. So it is 2/3. So gyromagnetic ratio in the case of the J equal to 1/2 is that 2/3. Secondly, and let's think that so in the 2s 1/2 state, in this case s means that L equal to 0, and also J equal to 1/2, so s equal to 1/2 because J equal to L plus s. Here it is the J equal to 1/2 and L equal to 0, so S equal to J equal to L plus S, then it is a 1/2, so S equal to 1/2. Then it is gyromagnetic ratio, it is 1/2 case is that 1 plus and also in this term is that 1/2 and also in this term is plus 1/2 times 3/2 because L equal to 0, so only S. So 2 times 1/2 to 3/2, so it is also it is 1/2, so it is 1, so it is a 2. In the 2s state, 2s 1/2 state is the gyromagnetic ratio is 2. In general case for hydrogen, and only one electron will spin 1/2. So, and the total angular momentum L plus minus 1/2. So gyromagnetic ratio is that 1 plus J equal to L at first in the case for the L plus 1/2 case, L plus 3/2, and the spin is that 1/2 times 3/2 minus L plus 1 divided by 2 L plus 1/2 and the L plus 3/2. Then this numerator, this L square plus L square plus 2L plus 3/4 and minus 3/4 minus L square minus L, so cancel with each other and L square also cancel, so it is L plus 3/2. So then it is that 1 plus 1 over L plus 3/2 cancel with each other, so 2L plus 1/2. In the case of the J equal to L plus 1/2 case. In other words, and for J equal to L minus 1/2 case, and the Jg is that 1 plus L minus 1/2 L plus 1/2 plus 1/2 times 3/2 minus L plus 1 over 2 L minus 1/2 L plus 1/2. So in the numerator, in the L square minus 1/4 plus 3/4 minus L square minus L. So it is L square cancel, and also minus L minus 1/2. L minus 1/2 also cancel with each other. So it is that 1 minus 1 over 2 L plus 1/2. So by combining this one, and so in hydrogen atom, and in general, 1 plus minus and 2L plus 1 over 2L plus 1 in the for hydrogen atom. The hydrogen atom case and gyromagnetic ratio can be write down like this. So, and we already calculate for the Gman energy first perturbation is that the Jg, mu b b, and mj. So Jg is calculated like this, and so mu b b mj, and the gyromagnetic ratio is that 1 plus minus 1 over 2L plus 1. So it is final value of the perturbation of the Gman energy. So let me see this. Let me see this energy. It is energy, and for example, by applying magnetic field, and for example, 2p 1/2 case, in the case of the L equal to 1 case, and for 2p case, there are two possibilities in the here p means that L equal to 1 and J equal to 1/2. So S equal to 1/2. So and here there are two possibilities. One is that here total J is that L plus minus 1/2 case. So it one thing is that J and mj and Hamiltonian expectation. There are two possibilities. One is that L plus 1/2 minus 1/2, and spin up and spin down. In this case, and mj also 1/2 and minus 1/2. Then when we insert here, because L equal to 1 case, then it is 1/3. 1 plus 1/3, 1 plus minus 1/3. So here the mj, it is 1/2 case. mj is that mj is 1/2 case here, 1 half, and 1 plus 1/3, then it is that 1/3 mu b, and in the case of the mj is minus 1/2 case, it is minus 1/3 mu b case. In the case of 2p 3/2 case, there are 4 possibilities. One is that j equal to 3/2, and j equal to 3/2, 3/2, 3/2. I'm sorry, it is plus j equal to always 1/2 because it is j. Then mj is that 3/2, 1/2 minus 1/2 minus 3/2. In this case, and when we insert mj equal to 3/2 and L equal to 1, then 1 plus and the 1 plus 1/3 for 3, and also 1 minus 1/3 is that 2/3. So mj equal to 3/2 case, mj equal 3/2 case, it is 2 mu b. mj equal to 1/2 case is that 2/3 mu b. And also mj equal minus 1/2 case, minus 2/3 mu b, and also mj equal to minus 3/2 case is the minus 2 mu b. Okay. So there are 4 energy levels. 4 energy levels like this. It is a 2p energy level.